Hello everyone. Let's solve another Leetcode problem. Today we're going to solve problem 56. This is one of the problems within the blind 75 list. And in this problem, we are going to merge some intervals. So you already know what intervals are. Intervals are arrays consisting of the start point and the end point. So the problem description says that given an array of intervals, so you are actually given multiple of these intervals, right? Multiple of these intervals. And what we have to do is we have to merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So it will be more, the description will be more clear if I look at some examples. For example, for the first one, we're given these intervals. We are given like 4 intervals. And let's check whether which ones are overlapping. So you see these two are overlapping, right? Because 1, 3 and 2, 6, they're overlapping. 1, 3, if I draw them, it will look like this, right? And 2, 6 will look something like this. So they're overlapping. So they will get merged and become one interval like 1, 6, right? Okay, so 1, 6 is 1. You see this is 1, 6, and then 8, 10. This is not overlapping with 1, 6, right? So 8, 10 is separate. 8 starts from here, and then we have another one starting from 15. So this one is also not overlapping. So our result is going to be 1, 6, 8, 10, and 15, 18. Okay, so let's look at the second example here. Okay, so if you are given this question, you should ask your interviewer whether if the end point of an interval actually is the same with the starting point with another interval, then what happens, right? So in these problem, they are considered as the more overlapping intervals. So here is one thing, 1, 4, and let's draw this a little bit clearly. So this is 4, 5. There are 2 intervals given. And as you see, these two actually are the same, right? So this is merged into 1, 5. Okay, so 1, 5 is going to be the answer. Okay, so we have to merge all the overlapping intervals and return an array of intervals where each interval, all of the intervals are non-overlapping. Okay, so let's see another example. Okay, so another question that you may ask the interviewer is, can this input array be empty or of size 0? Yeah, because those are like the edge cases. Okay, so let's look at another input. So we see we have like, we have 4 intervals here. And we want to check, merge all the overlapping intervals. So one way to do that is take each interval and compare it against all others, right? To see if they merge or not. But that is a kind of order of n square affair. So one of the intuitions that we use to find the overlapping intervals in interval problems is sorting the intervals. So based on their starting value. Okay, so based on their starting value, you can sort the intervals. And you see, based on this starting value, if I sort the intervals, then what happens is this one becomes the first one, let's say A. This one becomes the second one. This becomes the third, and this becomes the fourth. Okay. So if I draw a timeline here, say like this, this is say 0, this is 18. Let's take the middle, 9, and then this is 3, 6. So we have drawn the timeline. Now let's draw the intervals. So this one will be something like this, A, right? This is A. And then B is going to be from 2 to 14. So it will be something like this, 2 to 14. So this is B, right? 2 to 14. A is 1 to 3. So this is B. C is 8 to 10. So this is C, 8 to 10. And D is 15 to 18. Okay, so sorting based on the starting value. The way it helps us is now when I'm checking the intervals, whether it's overlapping with another interval or not, I don't have to check against all the intervals. So when I'm checking B, I can just check against A, right? And then keep on doing the same thing. Okay, so let's say this is our resultant list. And we will actually keep track of the candidate interval that is going to be added in the result. So initially, obviously, the candidate is going to be this, right? This is going to be my candidate interval. So 1, 3. But should I add this to the result? Well, I can't immediately because this might be overlapping with some other interval, right? So I cannot decide yet whether I want to like add this or not. But anyways, this is the current candidate, the first one. We start there, and then we now start uh, iterating over all other intervals to check whether they overlap or not. So we start from here, right? We start from here and then keep on going this direction. So we start from B. So B, as we see that B is like it overlaps. You see, it overlaps with the current candidate, right? So if it overlaps, what we do is, okay, in that case, I have to change my candidate, right? And what I have to do is, I already know that I have sorted the arrays based on their starting point. So I don't need to change the starting point. Starting point is, for the candidate, the starting point is going to be lesser or equal to the current one. So, but I may need to change the endpoint, right? So I take the endpoint, maximum of the endpoint of this and the candidate, right? Current candidate. And now the candidate changes to 1 to 14. So I can just draw it like this. We can say these two intervals got merged because they were overlapping intervals. And this one now became this kind of thing, right? A and B got merged. And this one now becomes the candidate interval, right? Okay. Next I check C, right? I move to C, and do you see C is like overlapping with the current candidate, right? So in that case, since C is overlapping, so I have to try to make change to the current candidate. And you see C's last point is 10, right? So 10 is smaller than 14. So even if I merge C with the candidate, the endpoint remains the same. Okay, next I check D. Now you see, okay, so I have drawn C a little bit far. So 14 is going to be this. So it's going to, this is the current candidate. Now you see the next one, 15. This one actually doesn't overlap. So what we can do is, since it doesn't overlap, now I can say, okay, add. So the current candidates get added, 114. And so this is the current candidate. This is added. Now we have to set a new candidate, right? So this is added. The new candidate becomes the one that is non-overlapping. So 15 to 18, this one becomes the new candidate. This one becomes the new candidate to be added. By now we have exhausted our input. So that means this is also going to be, we say add this as well. So we add this 15 18, and then we are done. Okay, so this is our result. So let's try to code this. I hope the explanation was clear to you, and once we code this, it will be more clear. So first we check if intervals equals to null, that is, it is, sorry, null or intervals dot sorry, length equals to equal to 0. Let's turn this off. In that case, I return just the whatever list was the input, because I don't need any merging or any other thing. But the thing is, here in the constraint, I think it was told that there will be at least 2 intervals. So we can actually omit this, because that's not going to be the case in our test cases. But this is only if your interviewer says, okay, yeah, the input might be empty or null. Next, what you do is I initialize a array list of integer arrays where I will keep on adding the new candidates, right? Non-overlapping overlapping intervals, which we showed through candidates. Okay, so I initiate a list for that, and then say I will maintain the candidate interval. So let's call it candidate. Initially, I will initialize it with the first. Oh, okay. So before that, I have to sort, right? I have to sort the input. This is the input. So I sort the input based on their starting value. So if the starting value is based on their starting value, that means if 2 of the intervals are A and B, I will sort them based on their starting value. That means A0 minus B0. Okay. So now the intervals are sorted based on their starting point, and I will take the first one as my candidate interval, and then I will run a for loop from the second interval, right? So that's why equals to 1. Okay, and then I will check if the current interval overlaps with the candidate interval. So the way I check it is this is the current interval that I am checking, right? If the starting point of this is less than equals to the candidate's like starting point, sorry, end point, right? If the current interval's start point is less than equals to the candidate interval's end point, then they are overlapping. In that case, what I do is I have to change the candidate's endpoint, right? So the candidate's endpoint is going to be the maximum of the current interval's endpoint. So the current interval's endpoint is going to be 1, and the current endpoint for the candidate, whichever is bigger, right? So I potentially change my candidate interval. Yeah, so that's the only thing I do, right? Otherwise, if they are not matching, then what I do is else, if they're not overlapping, right? So if they're not overlapping, I can just add the candidate interval. So that means the candidate interval is now not overlapping. So I can just add the candidate interval to my result. And I have to assign the current interval as the new candidate interval, right? So candidate becomes intervals, right? Okay. Okay, so I keep on doing this, and once I am out of the for loop, now I have the last candidate, right? The final candidate that is still waiting there. I have exhausted all the input. So finally, there is the candidate left. So I add the current candidate, as you have seen here, right? Finally, this one became the candidate, and I just added it. Okay, so everything is in the result now, but this is a array list, so I have to return a 2D array, right? So I have to convert this array list into a 2D array. So result that dot to array, and for that I have to do this. So this is result dot size. So this is array list size, and we know this is each of these intervals of array of size 2, right? Okay, so let's try to run this. Oh, we have to return this. Okay, so initially I had made a mistake. So it was the first element of the first interval and the end element of the first interval, right? Okay, so this is going to be intervals, a typo. Okay, so test case is passed. Let's try to submit. Yes, so this one got accepted. So what is the time complexity for this algorithm? As you can see, we have done a few things. We have sorted it. So if the input size is n, and this one takes n log n, right? This is order of n log n. And then we have run a for loop, and where every time I just select one current interval and compare with again is the candidate interval. So this is I do run this for loop like n times. So this becomes order of n. And inside this, actually, I just do some operations in constant time. So overall, this is order of n log n and order of n. So the time complexity becomes, say the time complexity is order of n log n. Okay, and the space complexity, this one actually depends how much space we are not using any extra space anywhere. The only place that we may need extra space is space complexity, space for sorting. So it depends on the programming language that you are using, what amount of extra storage that particular programming language uses for sorting. Okay, so that's it. Thank you very much for watching. We will come back with another problem.